So from there. Now, so what is the least number of ticket stubs he can have? Assuming he has more than two. So if I write down all the numbers here that are congruent to two in mod 10, we'll start with two. And then just start adding 10. Then all the numbers congruent to mod 15. So 2 is congruent to itself. The next one would be 17. And then 2. And then adding 15 again will give me what? 62. There. And then do the same thing, all the numbers congruent to 2, mod 20, which would be 2, 22, 42, and then what? That's it. So what you're looking for is the smallest number other than 2 that is in all 3 sets. Any questions on that one? This was number 10. Any other questions? If you have your work, I'll take it. If not, you can email it to me, picture of it, right? As long as I get that before the next class, which won't be until after Thanksgiving break, I'll accept it, right? Okay. So if there's no other questions, I wanted to look at the birthday crowd. Didn't even occur to me to do this. Incidentally, I said I was born on Wednesday. It was actually Thursday. I never remember. Once again, just go on your phone. I'm sure Joy would do the same thing, but go to the calendar and you actually can just scroll back to the year you were born, like rapid fire. I just did a few scrolls and the next thing I know it was in the 1940s. I've heard that it actually goes back to year 1. Yeah, you keep scrolling. So I haven't tried it, but I've heard that. So anyway, asked you all to figure out what day of the week you were born, and remember the story of the kid from Huntington East who asked me what my birthday was, and I said, and instantly he said, "Well, it's Thursday." But he said the day, and it was correct. And I went back on the calendar just to confirm it, and it was a Thursday. So we're going to look at the mathematics used to actually figure that out. So definitely have something to write with. It's going to be a big old equation. I'll put on the board here in a second. A lot of heavy arithmetic. All right. What's that next? So here's your worksheet from years ago. Do this. And back in the 90s. So before we do that, I said this was going to involve using modulus, but it also involves a function that you may or may not have seen. Now, if you've had college algebra, you have dealt with this function. So it doesn't go really by that notation anymore. Does that make any ring any bells? That notation with the double brackets. No? Okay. Fair enough. Okay. They're the same. And if you've had college algebra, you would have seen this function. College algebra essentially is just the study of functions. So function notation, f of x. So quickly, a function, just kind of putting it simple, is a correspondence. You got a set A, you got a set B. And you have some way to take every element of A and what corresponded to one and only one element of B. So putting it into a simpler analogy, you take a kind of machine. It has an input and output. You input into the machine one thing, output is always what one thing. If you get two things out, not a function. And so it's always just really a question of knowing the rule. What is the rule that corresponds elements from that set A to set B? And then we give the set A a name called domain, and the set B things that actually are corresponding to, call that the range. So I mean, some simple functions. X is x squared. That is take what any real number and what's squared. So put in a number and square it, get to the output. Or absolute value of x. Input the number, take its absolute value. That'll be the output. So what this is and why there's actually two notations. This was originally the notation for this function. And with the advent of graphing calculators, this function is in there. You have to enter under the math menu. Does this. Now on the graphing calculator, this actually that graphing calculator, absolute value of x. But we still use this when you write down problems. And so why we didn't adopt this again, but for some reason, now you pick up any textbook, you won't find this anymore. You're going to find this, but it didn't happen here. I have no idea why. But anyway, not terribly important. This is called greatest integer function. So that's the name of it. And the rule is simply this: whatever you put in, and you can put in any real number. So its domain is any real number. So say I input 3.5. The output is the biggest integer or the greatest integer that is less than or equal to what you put in here. Less than or equal to. So in this case, the biggest integer less than or equal to 3.5 is 3. So the range is all integers. That's the only thing you can get as an output is an integer. If I put in 3, the output is still 3. Biggest integer less than or equal to. So we'll do one more. What would be negative 3.5? So we want to say what negative 4 in this case. So remember, order has reversed, going back negative. The biggest integer less than or equal to negative 3.5 is negative 4. Negative 3 would actually be bigger. Okay, so we're good. Greatest integer function. Any questions on that? All right. If not, let's do the birthday problem. All right, 3 inputs. Month, day, and year. All right. Now, day is simple enough. I'm gonna do mine, so you guys put in yours. So born on the 15th, so whatever day.
You have 15 on the month.
Thank you. Month. Now, if you were born March through December, just the normal number. I was born in September, so my month would be 9. But I'm gonna pick on you. If you were born in January or February, January put 13. February put 14. All right, now the year. A long time, 1966. Okay. If you were born in January or February, however, if you were born in January or February, put the previous year. So if you were born in the year 2000, then you were born in January, put 1999. What are we accounting for? Something that happens every 4 years. Leap year. We're counting the leap year every 4 years. So because our calendar is not perfect, and we model it's called a solar calendar, because it's modeling one trip around the sun. It's not exactly perfect. So leap year is making up for that. So I always feel bad for those people who happen to be born on leap year and were born on February 29th because they're okay. But, all right, so we have these inputs. Here's your equation. It's crazy. Just keep remembering that kid business is less than a second. W equals D plus 2 times M plus the greatest integer of 3 times M plus 1 divided by 5 plus Y year plus the greatest integer of the year divided by 4 minus greatest integer of Y divided by 100 plus the greatest integer of Y divided by 400. All right, so we got to come up with a number W. And basically at this point, it's just plug and go. We're going to plug these numbers in and do the arithmetic. So I will do mine. Six. 4.
Never going to be a fair fight. Was it with your cheerleaders? Back in unfair. It's unworthy of a WWE champion. So I decided to make some new friends. Oh, and that is when Woods and Big E are attacked from behind by the men.
All right. So calculate, of course, these were pretty easy on the greatest integers. Just do the arithmetic inside, see what you end up with. So like here, I've had 3 times 10 is 30, divided by 5 is 6, greatest integer, less than or equal to 6 is 6. Here, you get 4 is 1966 divided by 4 is 491.5. So greatest integer, less than or equal to that, 491. That would be 19.66, so then 19 on that, and then 4.915. There's 4, and then just doing the arithmetic, I come up with 2481. Now your number will be different. Has to be. Your year's different, your month's different, days probably different. Get this number. This is the number we are now going to use to determine day of the week you were born on. So what you are looking to do is we're going to take that W, find a number R that we are congruent to in mod 7. So we're looking to get a number 0 through 6. So for me, that's 2481. Divide 7 into 2004, or in my case, I'll divide 7 into 2,481. And look for the remainder. So for me, I get 3. Got a remainder?
No, I just got mine. No.
Okay. So. Here's that. 7. 1.
So everybody's log 7.
Yes, use mod 7. And the reason it's mod 7, that's easy enough to answer. There are what, 7 days to do. We're figuring out what day of the week we're born. So if you're a 1, so it basically goes this way. If it's 0, if 7 divided evenly, you were born on Monday. If you have a 1, you were born on Tuesday. And so on and so forth. 2 would be Wednesday. 3, me, I was born on a Thursday. And 4 would be Friday. And so 5 would be Saturday. 6 would be Sunday. So I got 3. Get it? Where we got the arithmetic? Got it? All right. So again, what baffles me is in doing this, I said 7 or 8 minutes, and then I was doing it by hand. I was dividing this in here. That was relatively easy. So I did this, and that's divided by 100, so I knew it was 19.6. But I had to write these all down, and then I had to add them up again by hand. So calculate 7 or 8 minutes. And that kid did it like this. Now, did he think it through this way? I doubt it very seriously. He couldn't describe me how he did it. Doesn't. Yeah, very exceptional. Any questions on this? So, do you guys, any questions? All right, I'm gonna actually turn your guys to the. board. All right, there we go. Okay.
Going to year one, and to my surprise, January 1st is on Thursday.
Ah,
I really thought it'd start on the Sunday, kind of sad.
it would make more sense if somebody was technically the first day of the week.
Yeah. Yeah, I'm expecting to start on Sunday.
Yeah. Wow, so how long would it take to get back to you?
Like, I had it done before you even started. this,
That,
'cause I
okay,
was
so it
trying
went
to-
pretty quick.
Yeah,
It was amazing. It was 2,000 some odd years. Technology. All right, so. We are finished up. with everything we're gonna do in chapters 4 and 5. So, now, so hopefully you guys can now see. And just out of curiosity, guys, how well can you see the screen? Daniel, Michael, Justin.
I can see it a little bit.
It's not showing up great.
Yeah.
Yeah, and I think it's a video issue. Not sure I can zoom that in any more than it is. So what we're looking at right there is our assignments page, or in my assignment manager, but it's just the assignments that we have looked at homework wise on my math lab. So ordinarily, this will be a paper test, and we'll be testing on this last bit of stuff we went over. But I don't have questions in my math lab relative to this, so it is what it is. That's why I was just collecting the homework. I will incidentally, this homework that I've collected, the last two things, I will add these into the grade book as an offline item. So if that's why if I don't get it from you by when we come back, then it'll just go in as a 0. So I'm going to treat it like any other homework assignment. All right, so, but we're basically looking at 4-3, 4-4, 5-1, 5-3, 5-4. So, and this will be the test. Now, it does say final exam. This is not the final exam. I'm going to edit that before I sign it and take that off. It is over chapters 4 and 5. We will. Just kind of reviewing back where we have been. 4-3 was short assignment and basically what lattice method, Egyptian algorithm, Russian peasant method. 4-4, which we spent a good bit of time, and so 45% or so of the problems on this test are going to be out of 4-4. This is converting from a number in a different base to base 10. And from base 10 to some other base, the direct conversion from base 2 to base 16, base 2 to base 8. We looked at ASCII, percentage of information interchange. All right, so that was all 4-4. 5-1. So here we were looking at divisibility, prime numbers, factoring, writing out the factors of the number, prime factorizations, and we won't have to go back questions on the divisibility test for 7 and 11. Finding the number of divisors. And okay. So that was 5-1. 5-3. Abundant, efficient, perfect numbers. This had to do with looking at the proper divisors, everything but itself, and then summing that up. So if the sum of the proper divisors of a number is greater than the number we said it's abundant, it is less, it is efficient. If it's exactly the same, like 6, it's perfect. 5-4. GCD, LCM. Okay, that said, the test itself is short, 15 problems. I will allow 2 attempts. I'm going to assign this, so sometime during Thanksgiving break, take the test. And so looking at where the problems are pulled from, 4-1, 4-3, notice 1, 2, 3, 4, 5, 6, are out of 4-4. 5-1, 5-3, and 2 out of 5-4. And again, I will assign this for 2 attempts. As a matter of fact, I'll do that now. Off. All right, so I'm putting a due date. We return on the 30th. Attempts. Due date. It is now up and assigned. So what I need you guys to do over Thanksgiving, one, I would suggest you get the paper done. Just so it's done, that is off the table, you do not have to worry about it once we get back. 2, take the test. It's 15 questions. So it's not like it's going to be excruciatingly a long time to take it. So get that done. If you have outstanding homework, take the time during Thanksgiving break to get yourself caught up. So you're not down to the wire. Before we get back, I will do managing completes, which that is any assignment you haven't started, and I haven't done managing completes on. There'll be zeros in there. So, and that is it. So otherwise, I don't have anything else today unless you got some other questions. And I'll just say happy Thanksgiving. Be safe and So definitely, if you go out in the woods, be safe. Hopefully, there won't be, snow. All right, guys. See y'all.